and welcome to my Exam 2 screencast. So jumping right into 1A, we're identifying the different variables in the system. So the control variable is x in this because the goal is to keep x constant despite changes in x1. And since there are changes in x1, like variations, that shows that x1 is the disturbance variable, and its disturbances the system needs to adjust for, and it adjusts for these by measuring x and then coming up here and changing the valve here to let more W2 go, or like less W2. So that means that W2 is our manipulated variable because it is adjusted by the valve based on info from X in feedback control. Moving on to D. To derive these, I pretty much used practice quiz 7, like the same steps for that. So I started with a component mass balance, and then since rho, A, and H are all constant, the problem tells us H and rho are, and then we know the area is constant, so we can pull those out, and then linearize it based on what's changing. We know that W1 and X2 are constant because it says so in the statement. Oh, and just to go back, like these are the process and disturbance transfer functions that we need, which we get from the loop that we drew up here, the block diagram. Then we can Laplace our linearized form here, and then like put like terms together and solve for x prime of s as a function of x1 prime of s and w2 prime of s, and then we can get our transfer functions by holding the other one constant. So like for x prime of s over w2 prime of s, we send like x1 prime of s to 0, so we just ignore that, and then basically we put these into standard form, so we have that plus 1 over here instead of a different plus constant, and then we can pull out all of the numerators and taus and figure out what the constants are in terms of the values that were given to us. And then down here, I have the final things, and then I just carried through all my units from what the problem gave us. F was tuning a controller. We set tau C equal to 1/3 tau dominant, which is going to be the bigger tau. In this case, it was 3.93. Basically, this is a lot like practice quiz 7 again. So we start with our overall transfer function for the system. Here, we multiply it all out and we get it into this form. And then we see on the IMC controller tuning settings handout, we see which model it best matches. For this one, it was model I, just like the practice quiz. And then I went in here and I figured out all of the values based on what the model has. And then yes, this tau C, and then just solved for my KC, tau I, and tau D based on what the sheet had. And then this is the form since it's a PID controller. Okay, moving along. Okay, now we're going to go into the homework problems. So problem 15.3 was a separations problem using feed-forward control to control CO2 concentration, and then manipulating QA. And then it also said that the inlet flue gas flow rate was the disturbance variable. So here we go. I attached your solutions for this. Okay, here we go. The first thing I noticed was that it gave you like how the CO2 concentration changed as these different flow rates changed. So I did a linear regression in Excel and they had super high R squared values. So it was like allowable to use that linear regression and that information from there to figure out the relationship between these two and then these two. And we use that to get gains for the respective gains. And then here we drew a block diagram. Basically, this is a lot like practice quiz 8 that we just did and like feed forward control. Basically, we have here, I'm going to go over to this part. This is a lot like this section. We have feed forward control coming from T naught in this case, or QF in this case, and it's getting fed forward to affect the CO2 concentration. And then to use steady state design to design the system, we start with our overall transfer function, and since we want it to be y of s equal to 0, basically we're going to set this numerator equal to 0 and then solve for gf. From there we can use our linear fits to get our k's. Oh, we can use k's instead of g's because it's steady state, so all of our taus and everything are going to go to 0, and we'll just have K's instead of G's, and then from there we can just solve for this by plugging in all the values that we got from the linear regression. Okay, and then problem 16.5. This was basically practice quiz 8. We were trying to control T2. So this control system can operate, let's see, I'm just going to start by talking about this. It's cascade control with also feed forward control. Basically, the feed forward control is shown up here, and then the cascade control is because there's two nested feedback loops, and the second controller's output is going to be the set. No, the first controller's output is going to be the set point for the second controller. Coming back here, we know it's cascade control because there's two nested feedback loops and two controllers, one there and one here. And then also, we know that T1 is an internal variable since it's affected by V1, which affects Q2 and T2, and then comes back to affect T1. And then, yeah, this is the block diagram was also in the practice quiz. Okay, thank you.